John Howie, and I felt no day-long program on big data would be complete without doing something that touched at least a little bit on security and how the data gets used and where it goes. So we've invited John Howie here today. He's the COO at the Cloud Security Alliance, a not-for-profit organization that promotes best practices for security assurance in cloud computing. Before he went into the alliance, he managed the groups responsible for data center security in a quote-unquote leading cloud provider, which shall remain nameless. Like with many of our other speakers, this is a person who goes back and forth between industry and academia. So he is a visiting professor at Edinburgh's Napier University as well as the University of Arizona. And he is, in addition to that, an advisor to the UN Interregional Crime and Justice Research Institute. So join me in welcoming John Howie.
Thank you very much. Thank you. When I was asked if I wanted to come here and present today, I jumped at the chance. Full disclosure, I did actually work for Microsoft. That was a leading cloud provider that will remain nameless. But I heard that about half the audience here are Microsoft, so you are my former colleagues. So I always like coming back because I like the green water, the lemon lime water. And so it's always an excuse to come back here. So I'm going to talk today about big data, principally about some of the uses to which we're seeing it being put, and some of the potential consequences. I'm not going to make a statement that it's good or bad. I'm just trying to raise awareness. That's all I really care to do today. I'll leave it for others to judge what the impact of big data will be on society, but there will be an impact. It's just what that impact will be, I think, is yet to be decided. So a little bit about me. In the introduction, you heard I'm the Chief Operating Officer for the Cloud Security Alliance. I'll mention that briefly in the next couple of slides. But I also do work at the University of Arizona and at Edinburgh Napier University. And I'll talk about some of the stuff we're doing at the University of Arizona because it has consequences for big data and privacy. And I'll give a very real, concrete example towards the end of my presentation. So this is just an overview of the topics I'll be covering in this presentation. I'm not going to go through it in an exact order, but we're going to touch on these themes. I'm going to give an example of big data. It's one that many of you have probably heard about before, or similar examples. I'll explore it a little bit. We'll talk about the rise of big data, why we are where we are today, why big data is such an issue. We'll talk about the explosion of data sources, and this is something a lot of people aren't really considering. You think we have a problem with data today, it's only going to get worse. And how we manage those data sources and how we manage the impact to society of those data sources and data collection and data use are things that I think we've yet to find answers to. We'll talk about the privacy impact. We'll do that throughout the presentation. And then I'll give an example of government use of big data. Not in the context of PRISM or NSA data collection or anything else that you may have heard about in the recent weeks and months, but in something that could still have a huge impact to government function, government budgets, and personal privacy. So very quickly, just about the Cloud Security Alliance, we are a global non-for-profit organization, and we produce research. And all of that research is available on our website free of charge. We do not charge for it, including commercial reuse. So you're free to download that information. You're free to use it in your research. You're free to put it into your products, your services. You're free to promote it. In fact, please promote it for us. We'd be very happy if it cut back in our marketing bills. So it's all available free of charge on our website. We're a young organization. We're only about 5 years old, 4.5, 5 years old. We have about 45,000 individual members. We have 150 corporate members. The leading cloud providers and big data providers are members of our organization, and we have offices around the world. And not surprising, we actually do some research into big data as well, because you're seeing the cloud and cloud computing being used to facilitate and further big data and big data analysis. You know, you can go out and you could buy a data center worth of servers and storage to do big data analytics. But unless you're going to be doing it 365 days a year, it's probably cheaper and easier for you to rent that processing power and that storage from a cloud provider, including Microsoft with Windows Azure or one of the many other providers who are offering, in quotes, Hadoop as a service. And so you can go to our website and you can download some of the intellectual property, some of the research that we've done in this area, including what we call the top 10 threats to security and privacy of big data. We just released an update to that report last month. So let's jump straight in, because I only have about 30 minutes, and talk about everyday use of big data. And here's an example which you find often quoted in the press. And this is from Forbes, from their website, but it's actually a retelling of a story that appeared in the New York Times. And it's how Target figured out a teen girl was pregnant before her father did. And this is a very common use of big data today. It is where an organization for marketing and sales purposes collects information about its customers and then uses that in targeted selling. In this case, content was arriving in their inbox and at their house in the form of flyers and special offers for someone who was, in all likelihood, pregnant. And the father in the household was looking at this going, why am I getting this? My wife's not pregnant. No, his teenage daughter was. And this was an invasion of her privacy because her family members were made aware of her medical condition without her consent in what is essentially a perfectly benign use of big data. When people talk about government surveillance on individuals, I don't discount the possibility, but I always point out that if government truly wants to know a lot about me, all it has to do is go to Safeway. That is my local grocery store. And I have a Safeway Club card. And as a result of sacrificing some of my privacy, I get steep discounts on products I purchase there. For example, I typically get about 10 to 15% off my grocery bill when I shop there. And I collect points that I can use to get discount on gasoline purchase. My wife just cashed it in and got 70 cents off a gallon of gas and filled up her tank and saved about $9. Seems like a really good deal to me. But in return, Safeway has this database about me. It knows more about me and my wife than the US government does. Let's just go into it. It probably knows I'm a vegetarian because I don't buy meat, but I do buy Boca burgers and veggie hot dogs. It knows how often I eat them as well. It knows I like oatmeal and not Cheerios, for example. It knows that I prefer organic foods versus non-organic foods. That's not too bad. Yeah, we're not really getting creepy yet. But let's look at the creepy side. It probably could figure out when I'm having a fight with my wife based on how often I buy condoms or how much alcohol I purchase. Just saying. And this supermarket has all this information about me. So if the government wants to know about me, it doesn't have to invade my privacy directly. It could just subpoena the records from Safeway. And it could probably build this profile of me. And it could probably get this information from other direct marketers as well. And it could build this really good picture of who I am, what I like to do, and when I do it. It'll also know when I'm out of town because I'm not shopping at Safeway. And so it gets all this information. It doesn't have to follow me directly. It can go to the stores and the vendors that I purchase stuff from because they're collecting all this data in order to further their own sales and marketing efforts. So why is big data so possible? How come it's so easy to amass all this information and process it? Well, there's two laws that come into effect. One is Kreider's law. And this basically says that by 2020, although I'd argue it would be a lot sooner than that, a 2.5-inch drive with 14 terabytes of storage capability will cost $40 US. That was a prediction made in 1999, I think it was. We're probably going to beat that date. It's probably going to be available beyond then. However, that 2.5-inch drive in the original law was a two-platter hard drive. I actually think it'll be a solid-state drive. I don't think it'll be a magneto drive or a magnetic drive. Disk storage has largely kept pace with Moore's law. Moore's law itself, to boil it down into its base form, says that computing power doubles every 2 years. As a consequence, and by the way, here's some charts that show that, as a consequence, it's now cheaper to keep data than to delete it. Think about your organizations. If you work for Microsoft, think about the amount of data that comes into your inbox, the amount of files that you probably download into your hard drive. You probably pull them out from SharePoint or a file store because you want a personal copy for easy reference. It's now easier for organizations just to give up trying to delete data and just keep it all. I was at a conference a few years ago when I actually said this, and I got roundly not shouted down from the panel, but people somewhat verbally disagreed with me, saying, no, it's always easier to delete data and it'll always be cheaper to delete data, because their thought pattern, one of them was a lawyer, was that if you keep data, it's discoverable, and in a lawsuit, it might actually hurt your organization. And I said, guess what? The chances of that happening and the impact of that are far less than the costs of actually figuring out who has data in the organization and making sure it's deleted in accordance with your data governance practices. Data governance practices used to say email you keep for 6 months and you get rid of it. That actually, by the way, came about because the ECPA, the Electronic Communications Privacy Act, and a provision that allows the US government to get access to email without a warrant if it's older than 6 months old, because it's been considered abandoned. The law, I think, has changed from that point, but that was where that law first came from. And other people would say, well, if you have a Word document, only keep it for 3 months because the chances are the contents of that word processing document have changed anyway. And so organizations with data retention policies used to try and mandate data deletion. Who does that anymore? We don't do it. In fact, organizations are now figuring out that all that historical data they've kept, there's value in it, and that they can now mine that data using this increased processing power, because all that data is available because of cheap storage, and they might be able to derive value from it. And the classic example you get is in manufacturing industries, where they'll analyze data that they have kept for years and years and years because they abandoned data deletion and data retention policies in general, and they're looking for patterns in that data which predate an incident or an event that may have impacted manufacturing. For example, a broken conveyor belt or a machine breaking down, or a spoiling of food or spoiling of goods or services which are being produced, in order to try and find patterns so they can predict when it might happen again. And businesses themselves, routine businesses, not manufacturing businesses, are starting to do the same. And because we've got such powerful computers at our disposal, our laptops and our desktops, we're now indexing all of these documents, both structured and unstructured, on our desktops, and we're collating that information, and then we're feeding it up into the cloud, where it's being processed even further to analyze and mine that data. And it's all happening transparently in the background. We're not doing it. It's built into the operating systems. It's built into the applications. And so now if I do delete a crucial document that might exist on my hard drive, and it turns out I absolutely have to have that information, except it's 2 years old, the chances are I can find out who else has a copy by going to a central indexing service within my organization and finding out who has it on their hard drive. And I can get that data back. It's becoming that simple to find data and to mine data in an organization. Now, governments themselves gather a vast amount of data. They do it for a number of different reasons. And the vast majority of that data that's collected is really public information. There's nothing sensitive about it. It's routine information about how a government does business, how it interacts with its citizens, how it collects its tax revenue, how it creates policy. There's very little that government captures and builds in terms of information which is truly secret or confidential. Most of it is completely open. And so in recent years, there's been a drive by governments around the world. The US and the UK are arguably two of the leading governments in this space, but there are others, to publish all this taxpayer-funded data and make it available for use. Just push it out there. After all, you, the taxpayer, you've paid for it. Let's give it back to you. And if you can make use of it in some way or some fashion, great, wonderful, let's do that. So it's intended for use by researchers and application developers. The rise in application development that can capture these, I'm looking for my prop, that can capture and use these data sets is mobile computing. It's our phones and our tablets, even our laptops. And you're seeing these application developers swarm to these data sets and using them in ways that government can't conceive of and can't afford to develop or exploit anyway. But it can be used for citizen enrichment. So that's the rationale behind it. But there's also no barrier to corporate use whatsoever. There's nothing to prevent an organization, whether or not it's domiciled in the United States or the UK, from accessing those same data sets and using them for their purposes. And so here we see the US data.gov website. I actually snapshotted this page because it's got inventory of bridges in the US. I don't know if you heard, we had a bridge collapse here in the Pacific Northwest just recently, so I thought that was topical. There's over 1,200 data sets of bridges alone in the United States. 1,200 data sets in just bridges. You can imagine what other kind of data might be available. So if you're a construction firm, you might want to mine this data, and you might want to target states with vulnerable bridges and say, hey, we'll come in and we'll repair them all for you at a really cheap price. That's one of the potential uses of this data. Of course, what happens when you have data about individuals, which governments are also publishing? Because they do, and I'll show you an example of that in a couple of slides. This is the UK website. I pulled this one up because I wanted to know what bathing quality data is. Anyone got any ideas? I mean, I'm a UK national. I was born there. I also have a US passport, but I can assure you my shower works just fine in my house back in the UK. So why they've got something on bathing quality, I have no idea. But it shows you the weird types of data that governments collect and then make freely available now through these websites. And you can download them and you can use them. Interestingly, the UK does have a code of practice over dataset use, which you can get to from their homepage. But it's only a code of practice. It's not a set of laws. So at least the UK government is saying, hang on a second, there may be unintended consequences or societal impact to privacy by making this data available. So they've at least come up with a code of practice around that. Let's return to the US. I found this data set in about 10 seconds of searching on data.gov, which is the US website. And it is census data to target the uninsured. Now, when the census was first begun, there was all these assurances put in place that no information about individuals would ever be released publicly from the census until after everyone who was collected, information collected, is dead. That was the original goal of the census, because there were concerns about census data when it was first started, the US Census. Same in the United Kingdom. But this data is only 2-3 years old. And if you go into this data set, you will find all kinds of information such as county, some cases city, age group, ethnicity, and a whole bunch of other information. And as I'll talk about in the next few slides, relatively sophisticated organization could mine this data and could identify personally every person in the US who doesn't have insurance as identified by the Census Bureau. And yet their names and their actual addresses are never published in this data set, but you'd be able to find them relatively easily. And this is one of the unintended consequences that we have about putting government-collected data available online. So the use of public data itself, intended for researchers and academics, but freely available for commercial reuse, is immensely useful. Let's not throw the baby out with the bathwater. It is incredibly useful, both to sociologists and to anthropologists today and in the future. Think about it. When we look at society 200 years ago, we have very few records. We have parish birth and death records. We might have some early census data. We may have some more information about historical figures. We may have family Bibles with handwritten notes in them. We may have diaries. We may have personal letters. But that's pretty much about it. Not true today. In 200 years in the future, someone will be able to mine the Safeway data and get all that information about me and my wife, that they will know what I eat on a daily basis. And they'll know how much I drink, and they'll know all kinds of other things about me. Things that we would never know about people 200 years ago. We might be able to make intelligent guesses, but we truly wouldn't know. And yet the amount of data that's available today will be of immense wealth in the future to understand humanity and the development of society. But other researchers are finding use for these same data sets published by the government about government business transactions and interactions with citizens. On top of this, you also have a wealth of private data which is being made available too. Many companies sell data. Back in the dot-com era, it was just email lists. And that was controversial at the time, and it led to all kinds of legislation, including CAN-SPAM Act in the US and others around the world. But today, it's a lot more accepted that an organization will sell information it collects about you in the course of doing business. In the banking industry, it's somewhat restricted by Gramm-Leach-Bliley Act, and you have to check off whether or not you want that information shared. And so the risks are often underplayed or misunderstood. But that information sharing does take place. And then often the language is couched about the information sharing activity is couched with the terms, we will anonymize who you are. We will use pseudonymization techniques so that you will not be personally identifiable in the data set that we're releasing, the information that we're sharing with others. We will not identify you individually. However, there's a problem with that. So here's the most recent example. This broke just last week. AT&T to sell users' anonymous usage and location data to advertisers. So if you're an AT&T customer, by the way, I am one, my information, unless I choose to opt out, not opt in, but opt out, will be shared with marketers and advertisers. When they'll be able to use that information to determine whether or not I'm a viable target for marketing activities. But me, myself, as an individual, my username, my name, my address, my account information shouldn't be sold or shared. It will just be my, in quotes, usage data. Where I am, how often I make phone calls, the duration of the phone call, how often I text, how much email I use. Not the contents of the text and email messages, but just the fact that I'm engaged in this activity. Except 3 months ago, this story broke, which says anonymized phone location data, not so anonymous. In fact, researchers in Europe said they were able, with high degree of accuracy, to take phone location information and actually identify individuals from it without knowing who they were. And so AT&T just last week said, hey, we're going to sell this and share this information, even though 3 months ago researchers said, hey, with enough information, we can identify who you are. There's also a problem when we start to combine data sets. So even if you have a data set of information about individuals which their identity has been removed from or made pseudonymous, you might be able to actually integrate it with another publicly available data set or one for sale and start to identify people. And that happened, and the first, you can't really see the two cutouts there, but the first one says re-identification of individuals in Chicago's homicide database, a technical and legal study. And they took this information about people who had been murdered in Chicago, which didn't have their names or addresses, but they were able to correlate it with Social Security information and 100% accurately identify everyone who'd been murdered in Chicago who was contained in that data set. And they took two sets of information, and both were publicly available, and they're able to uniquely identify individuals as a result. The bottom one is simple demographics often identify people uniquely. And this is an often quoted study, and it comes out of Massachusetts making available anonymized healthcare data about government employees. And up there, 87% of Americans can be identified with just 3 pieces of information: zip code, date of birth, and sex. Just 3 pieces of information. Computer parlance, that's what maybe about, let's say 8 digits for date of birth, 5 digits for zip, not even going for zip plus 4, and my sex, 1 bit. So in about 24, 25 bits of information, you can uniquely identify 87% of people in the United States. And so you could see that AT&T would say, well, we're not going to share your name or your address, but we'll give your billing zip. And we'll give your sex, male or female. And another data set contains some other information, but it contains my date of birth. You bring the two together, and suddenly I'm identifiable as an individual. Not my name, but who I am, where I go, how many phone calls I make. And you can start to correlate that with other sets of data to uniquely identify me. Maybe buy that Safeway data set and bring the two together. Who knows? But there's also government interest in big data as well. And this comes to the fore because of all kinds of problems that Western societies are facing. And that is budget and budget debt and national debt. And here are some statistics which were released just earlier on this year. They're not big data statistics themselves, but they put everything into sharp relief. Direct cost of diabetes in the United States was $245 billion in 2012. Massive increase in the 5 years from before, where it was $174 billion. Roughly 20% of healthcare spending in the United States is on diabetes and diabetes management. The indirect cost to the U.S. economy of diabetes is almost $70 billion. Combined, it's just under 10% of the U.S. budget. Just under 10% of the U.S. budget. Actually, yes, just under 10% of the U.S. budget. So if I'm a policymaker and I say, well, hang on a second, can I use big data to cut those costs? What can I do to actually identify why we're spending so much money, where the increase is coming in healthcare costs or in diabetes? What can I actually do to cut my Medicare and Medicaid budgets by eliminating the need for these costs? Because that way I could get rid of the national debt faster. Well, it turns out that it may actually be possible today to make dramatic impacts in those numbers, but at a cost to our privacy. And this comes out of some of the research that we're doing down at the University of Arizona that I want to talk about in the last few minutes I have here. We started looking at insider threats and deception detection. And this came out of a government-funded project to identify people who were coming to the US who intended to overstay their visa or stay here beyond the terms of their visitor waiver or whatever. And we took a lot of the algorithms and the work that we did in that space. All, by the way, the algorithms are all vetted by big data and lots of government data which was made available to us. And we actually boiled it down to being able to identify insider threats within organizations of all sizes. So we can reliably detect when someone is lying to us by how they interact with a computer or how they answer surveys. A lot, again, the algorithms all validated with big data. And then we had an epiphany. Well, hang on a second. If we're now monitoring how people interact with a computer, are there healthcare applications? Yes, there are. There's actually a whole bunch of them. In fact, we just filed a patent for one of them. And that application is, when you're a diabetic and you're about to go into an insulin imbalance or diabetic shock, one of the first most noticeable things that happen is you have a hand tremor. One of the first most noticeable things. And you can imagine that you'd be able to capture that on a computer or a tablet as someone is using it, or even holding a phone, because you would detect a jigger in the mouse, or there'd be a change in how the keys are pressed in the keyboard, or how someone holds a phone or a tablet device or interacts with the touchscreen on a device. So would it be possible for the US government to actually monitor everyone in real time who's a diabetic and then warn them that they need to take their insulin if these tremors start to kick in? The answer is yes, because about half of the direct spending today in the US on diabetes is dealing with diabetics after they've gone into shock and are hospitalized, or the long-term health care implications of repeatedly going into diabetic shock. And so we could very quickly cut those costs. So government is looking at using big data in interesting ways to cut the budget. And you might argue, well, that will never happen in the US because it just won't happen. But what about countries around the world with socialized healthcare like the United Kingdom, the National Health Service? They might do this because they want to cut their costs, and it's all taxpayer funded. So governments themselves are also looking at big data in interesting ways. So in the couple of minutes I got left, just some very high-level guidance. Anonymization and pseudonymization strategies need to be closely examined. And that's because within a single data set, you may have preserved anonymity or hidden the identity of an individual. But when you combine data sets or correlate data between data sets, that identification may be possible. Consent to release private data should always be obtained first. In the AT&T case, what they're saying is, we're going to release it unless you opt out. And they're mailing everyone with their updated privacy policy. I don't know how about you, but I get privacy policies all the time. I throw most of them away. So the problem is the consent is often implied in a contract, and when you get that notice in the mail, it's we're just sending you our annual privacy notice, and no one thinks to check it. You didn't keep last year's one, and you're certainly not going to go 32 pages of privacy legalese to see if there's been any changes. And then people will say, well, if we prevent co-location of data, it will make it impossible to actually look across multiple data sets simultaneously. I can tell you that's not the case. Although networking speeds have not kept pace with Moore's law and disk storage, it's certainly becoming faster and faster, and accessing data sets across multiple data centers is really not a problem anymore. The biggest issue, however, and this is what I want to highlight to you, is causation versus correlation. We've already started to see that we run the extreme risk that developers of software and their managers and business people in general, without any research experience, will jump to conclusions. They'll actually look at data and say, oh, if this is true, then that must be true, and this is the cause of that. That is not the case. And we have to educate everyone. There's a difference between causation and correlation. And we haven't done a really good job at that in computer science anyway, and because big data is going to change how we look at data, how we interpret data, how we manage data sets. We have to get this across. This is a key thing that we have to educate people about, causation versus correlation. So that's it. It was only half an hour. Thank you very much. Here are my contact email addresses for the Cloud Security Alliance in Arizona and Napier in the UK. You can reach me in any of these 3 addresses. We have published big data research, which is available for your use free of charge. Download it from our website. You don't even have to register to get it. And if you have any questions, I'll be around for the next talk, and you can say hi. I'm going to try and stay for a coffee break as well. Thank you very much.